Hello, you are most welcome, ladies and gentlemen, to Real Impartation Moment on Tuesday Night Anatomy with Daniel Okwan. In today's section, we continue our journey regarding the developmental anatomy that we've already begun. So, if you've not watched the maiden edition regarding the week 1 of intrauterine life, where I looked at gametogenesis, fertilization, and then of course implantation, please get that video link and of course watch it. But for today's section, we continue, so therefore we go to week 2 of intrauterine life. And week 2 of intrauterine life, that is the formation of what we call the primitive embryonic disc. Okay, so the primitive embryonic disc, yes, is that kind of bilaminar embryonic disc. And we talk about, of course, the endoderm, and of course, that of the primitive endoderm, and of course the primitive, ectoderm. And I don't need to tell you that the primitive endoderm, we are talking about the hypoblast, and of course the primitive endoderm, we are talking about, the epiblast. So without much ado, let's set the ball rolling and look at briefly what happens to, of course, the embryo in the second week of intrauterine life. So there we are. Now, prior to this stage, what we saw was that, yes, if you look at the conceptus, okay, we had that of the blastocyst, and of course the blastocyst was having what we call an inner cell mass and of course an outer cell mass. Now the outer cell mass, yes, will give rise to, of course, that kind of will become eventually the trophoblast. Now, of course, the trophoblast will differentiate to become what we call the cytotrophoblast, and of course the syncytial trophoblast. Yes, we look at this one. Yes, we're looking at the utero placental circulation. Yes, when we look at that of the placenta formation. But for now, I want to look at what is really happening in the embryoblast. So the inner cell mass, which otherwise will give rise to what we call the embryoblast, yes, is what we are interested in looking at. So this area, okay, this area where we have the inner cell. So the inner cell mass will first differentiate into this cuboidal shaped structures over here where the cursor is running. These cuboidal shaped structures is what we call the hypoblast. Okay, this hypoblast is actually what we call the primitive, okay, endoderm, or let me say the first endoderm to appear. Okay, but of course we will definitely have to be replaced by the definitive one in the third week of intrauterine life. Okay, so this is what we call the first layer, which comes from the inner cell mass or the embryoblast. Okay, and this is what we call hypoblast, the primitive endoderm. Okay, and then it will be followed by, of course, this kind of the remaining portion of what we call the inner cell mass will elongate, okay, to form what we call the epiblast, and that is the primitive ectoderm. Now it is this epiblast which will eventually, yes, give rise to all the 3 germ layers, after the formation of something we call primitive streak. Okay, so we look at that when we look at the 10th week of intrauterine life, where we look at actually the definitive embryonic germ layers, okay, of the disc. So that is that one. Now if you look at this one, which we are calling the hypoblast, this hypoblast gives rise to this kind of cells, okay, these cells over here. And these cells, okay, is what we call the exocoelomic membrane. Okay, so these kind of cells which arise from this hypoblast cells, okay, is what we call the exocoelomic membrane. And it is, given an eponym, Hughes membrane. So Hughes membrane, yes, is the same as this exocoelomic membrane, which, arises from this kind of hypoblast cells. And this creates this cavity over here, and this cavity is what we call the primary yolk sac, which otherwise we call it, of course, the primitive yolk sac, because of course we will eventually get the definitive one, which is the secondary yolk sac. Okay, so we have this primary yolk sac, which otherwise, yes, we call it exocoelomic cavity, because the membrane over here is exocoelomic membrane, that Hughes membrane. Okay, so that is what we see. Now at the same time, what is happening is that these kind of cells over here, which this kind of epiblast cells over here, will also give rise to, differentiate to give rise to these kind of cells over here. And these cells, okay, is what we call the amniogenic cells. Amniogenic cells. And therefore, the cavity that will be created over here, okay, bounded by the epiblast cells together with its amniogenic cells, will be called amniotic cavity. Amniotic cavity. So that is, how we are going to look at it. Okay, so that is, essentially what we are going to see. So in the second week of intrauterine life, which, some people will call it the week of 2. Yeah, the week of 2, because yes, 2 germ layers are formed. They are primitive. We have the hypoblast formed initially from the inner cell mass, and then the remaining portion of the inner cell mass elongating to form this kind of epiblast. Okay, and this epiblast, yes, will give rise to these cells, amniogenic cells, to form the amniotic cavity. And then of course, the hypoblast cells also giving rise to this exocelomic membrane, or the Hughes membrane, to give rise to this kind of primary yolk sac. So it's the week of 2, because yes, we can see, yes, we looked at we having the outer cell mass and inner cell mass. Yes, the outer cell mass giving rise to trophoblast, which differentiate into cytotrophoblast, and then of course syncytial trophoblast, that's 2. If you look at the embryo proper, that's the inner cell mass, yes, giving rise to, of course, the hypoblast, and of course, the epiblast, that's also 2. Yes, you can also see that we have 2 cavities over here. We've seen this kind of yolk sac, and then we've also seen the amniotic cavity. Okay, now one thing that we've seen, this primary yolk sac, okay, will be converted in a way, okay, to become what we will get what we call the secondary yolk sac. Now, if you look at, if I should extend your idea somewhat, the germ layers, the definitive germ layers, we have we have 3 of them. We have ectoderm, endoderm, and we have mesoderm. We've seen that the primitive ones, we have the hypoblast, which is the primitive endoderm. Yes, we have the epiblast, which is the primitive ectoderm. Then how about that of the mesoderm? In the mesoderm, what we see is that rather we have a mesoderm, but that mesoderm is formed outside the embryo. Okay, that mesoderm is formed outside the embryo. That's where the embryo is. So that mesoderm, where it's formed outside the embryo, yes, we also see it in the second week of intrauterine life. That mesoderm is called, extra-embryonic mesoderm. Extra-embryonic mesoderm. Now, this extra-embryonic mesoderm is differentiated into 2 areas. Yes, by a coelom, okay, a large cavity forming in there. Okay, there will be a coelom, and that one will be called extra-embryonic coelom. Extra-embryonic coelom. So this cavity over here, which is found outside the embryo proper, yes, is called extra-embryonic, coelom. So that we get a mesoderm which is very close to, of course, the Hughes membrane, and of course the yolk sac, the primary yolk sac that we saw. Yes, that one, yes, is what we call the splanchnopluric. Yes, anything which is closer to yolk sac, yes, will be, giving rise to the viscera. So splanchno has to do with the viscera. So splanchnopluric, extra-embryonic mesoderm, and of course that portion which is, away, okay, is what we call the closer to the body wall, is what we call the somatopluric extra-embryonic, mesoderm. Okay, so the mesoderm is differentiated. Yes, the mesoderm is formed outside the embryo proper, and therefore we are calling it extra-embryonic mesoderm. It's differentiated into 2 by a coelom, okay, which is formed between them. Okay, and therefore we have the splanchnopluric, and then we also have the somatopluric extra-embryonic mesoderm. Okay, now the old concept was that yes, this extra-embryonic mesoderm we are talking about, is formed from the trophoblast. No, studies have shown that this extra-embryonic mesoderm is actually coming from the yolk sac, coming from the primary yolk sac actually, and therefore that portion of the primary yolk sac, that large primary yolk sac that we saw, has become smaller, because portion of it is replaced by this extra-embryonic mesoderm, and of course the coelom. Okay, it also gives rise to this kind of extra-embryonic mesoderm. Therefore, this yolk sac that we saw, very large yolk sac, yes, will diminish, will become smaller to become the secondary or the definitive yolk sac, yolk sac. Now, at this point, there is one concept that you have to get clear, that now we saw that this coelom formed almost everywhere. Yes, this extra embryonic coelom formed almost everywhere except this area where the embryo, otherwise the embryo will be hanging. So the embryo will have to be attached to one portion of this trophoblast. Okay, and this is what we call the connecting stalk. Okay, connecting stalk. So the connecting stalk, yes, there is no, that kind of mesoderm, extra embryonic mesoderm or coelom over there. So undifferentiated extra embryonic, mesoderm is what we call the connecting stalk. Yes, there's no coelom over there. The extra embryonic mesoderm is there, but there's no coelom over there. Undifferentiated extra embryonic mesoderm to connect the embryo, okay, to, of course, the wall. Otherwise, it will be hanging. And this connecting stalk is the future umbilical cord. We look at that one later. Okay, so this is that one. Now, there is another thing too that, yes, you have to also make mention of. That is the chorion. Okay, chorion. When we look at the placenta, we will also look at it again. When we look at chorion is nothing but this, somatoperic extra embryonic mesoderm, okay, that we have over there, together with, of course, the trophoblast. Okay, this one is what we call the chorion. All right, I believe you find this, week 2 of intrauterine life, very helpful. Please, if you've not subscribed to the channel, please do, so that as we go to the 3rd week, looking at the placenta, looking at, of course, that kind of pharyngeal arches, and of course looking at the systemic embryology, you also be able to appreciate this very well. I'm very grateful for your time this evening. Have a good night, and may the good Lord richly bless you.